Hello and welcome back to Universe Sandbox 2, everyone. And today we are going to solve the largest problem to most people for the future, and that's going to be climate change. Now, I know that's a rather large issue to try to tackle in a simulation in like 20 minutes that we have allotted for this video, but alas, I've got the perfect solution, you see. No, we don't have to ban cows, and we don't have to ban airplanes. We're just gonna hit Earth with a meteor. That is my solution. Now, my political platform will send out a rocket to, I don't know, an asteroid, whichever one's closest, and we're going to taxi it as close as possible. Actually, let's use, like, a minor object that's much larger than an asteroid, actually, because this needs to have quite a bit of punch. We're gonna try to modify the Earth's orbit. That's the plan. This could also be done by putting giant thrusters on the side of the Earth that only fire at a specific part of the day so that it's facing at the sun. But we determined that the hitting the Earth with, like, why don't we use the moon, actually? That would be the most efficient way to do it. The moon's right there. Just deorbit the moon. Okay, so we're gonna deorbit the moon to end global warming. That's a fantastic idea. This is the answer to climate change. Now, there are a few sacrifices that we have to make, but I think they are small scale. It's only a very small time frame that the Earth will be uninhabitable compared to the entire existence of the universe. Definitely no flawed argument there. Now, you may say this is going to kill a bunch of people, but what about the people that climate change is going to kill? Come on. Come on, you have to... If you are against this idea, you are actually against humanity. You're a bad person. Look at this. The problem is almost solved. If there's no water left on Earth, there can't be dirty water. Beautiful, absolutely fantastic. And now we're just going to let the fragments, oh, there goes the atmosphere. That may be a slight issue. Again, we've just gotten rid of literally all the pollutants in the atmosphere by removing the atmosphere. Very nice. Now we're just going to have to wait a few years for things to cool. Oh, we already have the atmosphere back and the ocean. Would you look at that? It barely took any time. What is it? Oh, it's 2014. Oh my god, the game was made that far back ago. It's been so much time. Holy moly. It seems like yesterday. So it looks like the most heavily affected people from this disaster is Asia. Asia is now a lot bigger. Specifically, East Asia now has another continent added onto. Oh, Asia and Australia are now connected. Yeah, who would have thought? That's an interesting turn of events. Huh, what is the temperature actually at? 7 degrees? Okay, so we did lose a bit of atmosphere, I believe, so what is our atmosphere at? Surface pressure in atmosphere. Oh my god, we lost half of the atmosphere. But that helps because it's colder now. So that's fantastic. Just make sure to wear your respirators. Because otherwise you're going to be out of breath. I wanted to come up with a good pun there, but it wasn't gonna be good enough for this channel. It needs to be high quality. Antarctica! Growing very well, impressively, and look, I mean, even during the summer, it's still, oh, wait a second, maybe I'm wrong. During the summer, is it hitting normal temperatures again? 7 degrees. Okay, the ice caps are growing. Gets down to 6 degrees. That's kind of cold. That's exciting. Let's graph the temperature to see how this trend is going. because I'm actually curious if we're about to hit an ice age. According to this graph, we are about to hit an ice age. The peaks each year are getting lower and lower and lower. The ice is getting very far down if we look at the preview window up on the top right here as well. Well, it's 3 degrees now. I think I may have done too well of a job. I may have broken the entire balance. It doesn't seem to be accelerating. It actually seems, the process seems to be decelerating, but that doesn't mean much when it's literally 2 degrees average. Oh wait, maybe it's gonna be okay, because things are steadying out. As long as it's above freezing, I'm gonna consider that successful. This is 2 degrees right here. It looks like a heartbeat. How happy Earth is. Oh my holy, that's why you don't use Speederson. Okay, we're gonna put it back to where it was. Okay, I broke the graph. Sorry, guys. I did in fact break the graph. Whoops. Okay, we can do other fun graphs as well. I wonder if we can do time passed compared to... Oh. Maybe not. Surface temperature. Visual temperature. Oh my... What is going on? Why is the visual temperature... Is that the temperature I see? Wait. Is that talking about the amount being radiated from the sun? I'm not quite sure. Tidal heating effect. 0. Of course 0, because there is no tidal heating right now. I like this new graph thing. I never really played with it much. Let's see carbon dioxide levels. Okay, so let's try to steady things out by adding carbon dioxide. How about we just add a bit, and we'll simulate carbon dioxide being emitted. Great. So we should, over time, see this going up. Temperature. You know, it's much easier if I just click here, and then I just do bam. Wow, now we can graph the temperature, which is now 8 degrees. Wow, we almost have it like stable and very cool. Oh, 8.4 degrees. That's not that bad. Oh, 9 degrees. That's fine. Nothing is going wrong. 9.1. 9.2 degrees. Seems fine. Nothing is Why is this doing this though? That's interesting. I don't know why it has that behavior, but I'm assuming that it can be explained by orbital mechanics or the seasons. That's kind of interesting. It has this double wave here. Well, what could possibly go wrong? I mean, it looks like the ice caps are receding, which is great news, because before they were 90% of the world. Let's just increase the rate at which they're being emitted. This is kind of disappointing. Let's go like 1,000 times. Oh my god. Oh my god. 1,000 times more carbon dioxide emissions is not helping. It's actually not even slowing down during the winter. The temperature is now pretty warm. It's now kind of at a runaway point. We'll graph this on the side. Oh, that's not what I wanted to graph. No, let me graph this. Yes, looking fantastic. Completely stable. Nothing could possibly go wrong. So I'll put this over here for reference. And let's just look at Earth and the beauty. Okay, so we're at like 50 degrees now. 50 degrees. Still looking pretty good. Still looking pretty good. Ooh, I can add... Nope, that's just Earth. Wow. Okay, so it's starting to slow down, though. That's the main point to take from this. Hear it. Okay, never mind. Never mind. It's... Oh! Oh, it dropped for a second there! Will it get to the point where the oceans boil away? That's the question. I mean, it's going pretty heavily, but now it's starting to dip during the... I'm gonna take that back, because that's not winter. That's just when we're furthest away from the sun. Okay. It looks like this is going to make a big curve. So it's going to go like this, and then I think it's going to flatten out. Now, it's not going to go down because that wouldn't make any sense. But the rate at which it's flattening out is actually pretty predictable at this point. So now there's no ice caps. There's none whatsoever. The oceans are receding, which is interesting because the ice caps melted, but it's just humid everywhere. Just wherever you are is humid. If you lived in Florida, I mean, no change. But if you live anywhere else, big change. Also, all plant life is dead. Just thought I'd mention that, except for in a few scattered places. Like, apparently tropical Africa's fine. They don't care. But, nowhere else is really doing well with this new weather. And you may be saying, how can you solve this problem? I don't know. This is pretty bad. It looks like it's going to stabilize itself, though. Maybe. Like, it's at 70 degrees, but maybe it'll stay. Oh, that's it. I think it's stable. Oh, never mind. That's the second wave there. So it goes, ooh, and then it goes down, and then it goes up a bit further. It goes down, and then it goes a little bit up. It goes up a little bit further, but the rate at which it's increasing is pretty slow, and it's continually getting slower. So, why don't we change it up and just, you know, industry. 10 times more carbon dioxide. Does the game just not care? I can't actually go any further because that's parts per million. Wait, it's 1,000,000 parts per million. So literally the entire atmosphere is now carbon dioxide, and you're telling me that that's not even that bad. I mean, sure, everyone's dead, but I want a molten death land. That's sad. Well, looks like it's time for me to, wow, 3,571 times pre-industrial. 2,565 times 2010 level. You know what? That's fine, but I'm just going to increase the atmosphere mass by 10 times. That should help, because I want to melt this planet. And if you don't let me wait a second, why did that make the... What? What? Why does having 260 Jupiters of atmosphere... Oh, wait. Doesn't that make us more massive? Nope. It just completely ignores that. Why did the Earth's... Oh, wait, we already know that because we hit it with something. Wait, but why... How can we have 260 Jupiters? How can we have suns of atmosphere mass? Milky Ways of atmosphere mass, and it's not doing anything. I guess we're just gonna turn off climate. This is kind of broken, I think. I think this is just a little bit broken. Well, I tried, I guess. I did try. Can't say I didn't try. I like how everything is just broken now. Oh well. That was enjoyable. We solved climate change. Let's just throw a meteor, or let's throw Io at Earth. Goodbye. Goodbye! I wanted to turn you into a giant molten ball of death, but apparently that's not a thing you want me to do. So I'm just gonna roll you. There we go. I'm gonna roll you so fast. Great. Now Earth is like the most deadly object in the known universe. And to demonstrate, let's put Jupiter next to it. What will happen when Earth hits Jupiter? Well, you might say, well, Earth has a relatively tiny mass compared to Jupiter, so that shouldn't really do anything. But if you said that, you'd be wrong, because the Earth is spinning so quickly. Actually, it's not spinning quickly enough. Okay, let's speed it up, because when you make things spin ridiculously fast, this game just gets really funny really quickly. One moment. Where is rotational period? Ah, let's just do... There we go. So now I have to like go to like microseconds to see it rotating. It's going so fast. Okay, ready? When it touches Jupiter, Jupiter is going to just explode. It's going to be beautiful. Jupiter is going to start spinning because it's like gears. It's going to rotate Jupiter on impact. I love doing that. I love it. That's beautiful. Okay, good job, Earth. The amount of damage, because it's gonna rip right through Jupiter as well. The collision isn't going to be like at one spot of Jupiter. It's going to be over like all of Jupiter because it's rolling so fast. Look at the mass of Jupiter just dropping extremely quickly. Why is the mass of Jupiter 0.0 whatever of Earth? Oh wait, that's a piece of Oh my god! Jupiter! Well, that did a bit of damage. Oh my god, Jupiter is now vaporizing itself. It's 30,000 degrees Celsius. That doesn't even make sense! Well, it turns out it just takes a really angry Earth to destroy Jupiter. And that, kids, is how you solve climate change. That is the solution. And I will see you all next time. Oh my god, what have I done?